welcome to the Algonax official channel. In this video, we are going to be building a simple voting demo. So we'll call it voting. Now we are on our interface and we'll have to get started quickly. So what the intent of this project is to build a simple app that would allow us to make users to vote between two options, which is disagree or agree. So there's going to be a start date for the voting to begin, and there's going to be an end date for the voting to begin. And then once the start date begins, they are able to choose to agree or disagree on their votes. And once they voted once, it will write to their states and allow them, and it won't allow them to vote again. And if they clear state from the program, it's going to remove their votes from the global state. It's going to reduce the amount of votes from the global state. So we would first get started by adding a method. So there are going to be there's going to be two methods on this route. So in this tutorial also we are going to learn about method overriding. So we could actually override default methods like the clear program. You could actually write a method to override the clear program, like the clear state program. So first of all, we would add the first method, which is going to be the voting. So what the voting is going to do for us is going to be to make the users choose their choice, to make their choice. So we call it cast vote. So in this route, what will happen is for the user to agree or disagree, and then a local state will be written to the account to identify that they've already casted a vote. Now what typically happens in such a situation is that before the user can actually make that call, that person has to have must have opted into the application, because without opting in you can't make use of a smart contract that is going to write into your local state. So the opt-in is just for you to tell the blockchain that you need the application to allocate a particular amount of storage to your account, and that you subscribe to it, making use of your account storage and incrementing your minimum balance. So that is typically what we're going to start with. So every typical TO program or PyTO program begins with like a decision. So the decision we are going to make here is to check first of all if the user has made a vote before, and then it would allow the person to vote, else it's going to cast a vote for them, or it's going to reject the transaction. It will also check if the start date is met and the end date is also not exceeded. Yeah, so now we are going to add a node, which is a decision, and then we will add the met node, and then we'll add the other routine node. So this is the basic structure of how the app is going to be. So we would start with adding our variables. So when we select the cast vote method, we want to add some variables to it, and those variables are going to hold each of the states, or the global state for that particular call, or the application as a whole. So we are adding a global state. We're adding a global state variable, like a variable that's going to read the state. But before we do that, we need to add a byte string that is going to be the key. So that key is going to be the start date. So we'll add the start date. So we'll just call it start date, and we could just use start date as the value of the variable. Now the next thing we want to do is to add another variable, another global state key. So the variable we are going to add is end date. So we could just use the value for that key to be end date. So these are the two keys for the start and end date. Then we are going to add a variable for the state value. That's the value of accepted or rejected. So there are going to be two, positive and negative. So there are going to be two state keys that are going to help to know if that particular vote is positive or negative. So there are going to be a number of positive people can actually positively vote it or negatively vote. So they are going to it's more like a down vote or an up vote, or a like and dislike. So we're going to add a byte string, and that's okay. We'll add a global state variable, which is going to be for the positive votes and negative votes, but we have to create the byte string keys for it. So positive, and then we'll just use positive as the string, and then we'll add another variable which is a byte string, and we'll call it negative. So it will just be negative. Now that we have this, we could also do another variable that is going to be the state for. We are going to do the variable that's going to hold the user's choice, but before we do that, we need to get the global state values for each of these properties. So we would have the start date key, and the end date key, and the positive key, and the negative key. So what we'll do is we'll add a variable. So that variable is going to be a global state. So it will be start date state. It will be start date. Now we'll add another variable, which is a global state. We'll call it end date state, and it would hold end date. And then we would have positive state, and it would hold positive. So we now have the states for each of these. So we'd also add we'd add the sender variable, which is an address. So we'd call it txn sender, and it's going to be the sender of the transaction. So what we want to do now is to also write the key, the state key, but we'd have this string as the state key. So we would call it let's just use choice, and the value is going to be choice. Then we would add the state, the local state, that's gonna be user choice. So the account is gonna be txn sender, and the variable name for the key is gonna be choice. So we now have the computed value to be txn sender and choice to be the key, of which choice is bytes choice. So we are getting the key choice from this txn sender, and txn sender is the sender of the transaction or caller of the app. Now once we've got this set in place, we could actually add an increment variable. So we're gonna do an integer, so increment is gonna be 1. So this is what we want to do. This is what we want to do, increment. Then the next thing we want to do is we'll add a variable, another variable. So let's see, we have the start and end date, we have the number of positive votes and negative votes, we have the user, the sender, we have the choice of the sender, and we have an increment so that we could increment it or not. So before we proceed with the cast votes, I think we need to be aware of the initialization of the application. So we would first have to make a global state, which is the global states created upon application creation. So we would have to make some global states, and then there would be start date and end date. So we just use values like we would use some fixed values, some hard-coded values. So we would add a global state integer, which is gonna be start date, and the value is gonna be a timestamp. So I usually use epoch timestamp converter to get timestamp values. So we could use epochconverter.com to get the timestamp values. So we could just get the current timestamp, so that is the start date, and then we could add the we need to use the same date with the key. We need to use the same date with the key because we have the variables here, and the start date, the key for start date is start date. Okay, so that is actually correct. Yeah, so we have that correct. And then we add another global state, which is also an integer for end date. So we could just add these values in seconds. So we could just add 100 seconds, or say, let's just make this 4. So that's going to be a date in the future, a couple of minutes, over 30 minutes. So we'd add the global state for end date, and then we also want to initialize the positive votes and the negative votes. And I noticed we didn't create the negative state, so we need to create the negative state, and that is going to be a global state. So we call it negative state, and the value is going to be negative. So we'll still go back to the globals, and then we'll add another state, which is going to be positive votes. So we have it to be positive, and we'll use it at 0 at first, and then we'll add another global, which is an integer, so we call it negative, and it will also be 0. So these are going to be initialized upon creation of the application. So the positive is going to allow the user account to have his or her state incremented, and his or her like the positive is going to increment when they vote for positive, and the negative is going to increment when they vote for negative. So what we'll do is the next thing we're going to do now is to make the cast vote. Since we have the start date, end date figured out, and we have positive and negative, we would also just make it that when the user votes, is going to write to their state. So what we want to do is, for every local state that is set, if it's not set, the value is going to be 0. So that's what we're going to use to know if the user has made a choice or not. And I mistakenly removed the user choice, so I would have to add the user choice back. User choice TXN sender and choice. So the next thing we'll do is we are going to do the decisions, which are to check for multiple conditions. So they have to be multiple conditions met, which we would have to start building up. So it will be an unconditional, and then we would add a routine that is going to follow each of those parameters. So first of all, we want to check if the start date, the current timestamp, is greater than or equal to start date, and we want to also check if the current timestamp is less than or equal to the end date. So we are going to add a variable that is going to hold it's going to be a global field, and it's going to be timestamp. So the global field is going to be latest block timestamp. Now that we have the value set, we'll then check for that. So we would add a condition. So it's going to be if the timestamp is greater than or equal to the start date state, and then we also want to know if the timestamp is less than or equal to the end date state. And then we also want to check if the user's choice is not equal to, that the user choice is equal to 0. So we need to add a variable here which is 0, and we'll just use a positive integer 0. So what we'll do is to see if the user state is not set already, which means the user has not voted already. And then we would also have, there's going to be an argument that is going to be which choice the user is making. So we'll add a variable to read the second argument of the transaction of the app call. So the argument is going to be a transaction field. So okay, we do not have it here. So yeah, we have an argument here, so it's going to be an argument. So we need the argument, which is pick decision, or we just call it decision. So we need a one indexed, so we need a one indexed index for the argument to be referenced. So we need index 1. So the first argument, which is going to be the decision, if it's a positive or negative decision. So we add the variable. So now we want to check if the user state, which is user choice, is not equal to 0, which means we want to check if it's equal to 0 if they've not voted before. So we'll add a condition which says user choice is not equal to 0. also okay, I think we have it all sorted out, but then we have to write to the user's state, which is the decision, and it would be user choice, and then we have a choice key. So we'll do since these conditions are met for the local states and the timings, which means we've checked successfully if they are still in the voting round, and we've also checked if the user has not voted before, we can now proceed with the votes and allow them to vote. So this routine is what is going to allow us to do something if all the conditions here are met. Now the next line of action would be for us to write the state to the user's account, which is the decision, and it will be written to the choice key. So what we want to do now is we first increment the state that has to do with the decision, and now we want to increment it by 1, so we have 1 already, and then we have to create a miscellaneous variable that is going to do that increment. So that variable is going to be a miscellaneous variable. Okay, so miscellaneous variable, and then we'll do increment choice. So it's going to be an arithmetic operation. So we want to increase the, okay, we have positive and negative state. So what we have to do now is we have to construct a state, a global state that is going to be based on the user's decisions. We have to construct a global state that is based on the user's decisions. So we would have to add a variable which is a global state. Now the variable name is going to be increment choice, increment user choice, and the key is going to be decision, which is the argument that the user has sent, which is positive or negative, and that way the decision is linked also to the positive or negative states. So we'll add this variable, and this variable is going to let us know that we are incrementing the user choice and is getting the decision of the user as its key. So we want to increment the user choice by 1. So we are adding an action node, but before then we'll do, okay, let's do an addition here. So the addition is going to be a miscellaneous variable. So increment addition, we'd call it increment user choice plus increment. So we want to increment the user choice by 1, and now the state, we are going to write that state as an action. So the action is going to be write global state. So the variable name for the state key is increment user choice, which holds the decision of the user as positive or negative, and the value is going to be incrementation. So we've increased the variable. So we want to write into the user state that the user can't vote again after doing that. So we'll do an action, write local state. So the account we want to write to is txn sender, and the state key we want to write to is user choice, and that is choice. Then the value we want to write is yes, we want to write 1. Okay, we are not writing 1, we need to write the decision as positive or negative. So we would write decision. So the decision is the key we want as positive or negative. And then we would also approve the transaction. So we would add an action, approve transaction. So we have this setup. So the next line of action we would follow is to write into the clear state program that is going to check if the user has has this state set. If the user has the state set, it's going to clear it, else it's going to just reject. It's going to just reject the transaction, or it's just going to accept. So what we do is, whether or not the user has the state set, he needs to approve it. But if the state is set, it has to be cleared off, and the global state attributed to that decision that the user has to be also removed. So we have, if you look at the documentation for ASC Builder, you'll notice that there is what we call overriding. So we could override default methods. So they are on create, opt-in, and then we could also alter the clear program. So we could add a clear program method. So what we'll do now is to add a method. We'll call it clear program. Now what we want to do for the clear program is to check if the user has the state set, the decision state set, or user choice set, and then we are going to clear it off. So we'll get user choice and check if it's equal to 1. If it's equal to 1, then we're going to clear it and then approve, and then decrement the particular choice they've made. Else we are going to just clear the state and then approve the transaction. So we have we're going to add a node, which is a decision. Now what this is going to do is, we need to also create some of these variables for the user for the clear program. So what we're going to do is, we would add a variable which is a byte string, and we would call it user state key, and the value is going to be choice. Now once we have that variable, we would have another variable which is local state, user choice, and it's gonna be txn sender, and then the variable that holds the state key is gonna be choice. Okay, we have user choice created already. Okay, choice of user, and we call it choice. So now that we have choice of user to be choice, we can also, okay, we also have the txn sender, but then what happens is it is not attributed to the clear program. So let's look at our results so that we could know what the program looks like. So we need to add a sender for this particular program. So we'd have to add a sender, so that is going to be an address, and we'll call it sender, and it's going to be sender of the transaction. Now that we have the sender to be the sender of the transaction, we could now add the variable once more, which is choice of user. So it's going to be a local state. Okay, choice of user, local state. So choice of user, sender, and then the key is gonna be user state key. So we have that set. Now the next thing we're going to do is we're going to check if okay, we have the state key, choice of user. We're going to check if that is set. So what we do is we need to create an integer which is going to be 0. So we'll add an integer 0 value, and we'll call it 0. And we're going to also have an incrementation, so we call it we just call it 1. So what we're going to do now in this decision, as I earlier stated, is going to be that we'll check if the state key is set, that's the choice of user is set, then we would remove it and then remove the votes from the appropriate global state. Now we also have to get the global state, and that global state has to be by the choice of user. So its value has to be the state from the choice of user, which is going to be positive or negative. So we would add a variable which is a global state, and it's going to be decrement from, because this is where we want to deduct the value the vote counts from once they've cleared the state. So we want to decrement from choice of user. Now that we have that set, we also want to look at the program to see if this is 1, int 1, 0 value is 0, and this is this. So we just want to do the decrement, so we'll add a variable which is a miscellaneous variable, so deduct. So it's an arithmetic operation. So what it's going to do is to decrement from -1. Now that we have that set, we also want to remove local state. Now we have sender and we have the state we want to remove. So we would add an action which is to remove global states or local states, but that is when we've done the decision. So we'd add the decision here, and we have the met node, and we have the routine, and in the met node we would have we would just have a condition. So the condition is going to be if the state key is set. So if choice of user is not equal to 0 value, Then the next line of action would be to remove local state first. So the action we'd add here is remove local state. So we want to remove it from sender, and the key we want to remove is the user state key that we created. And the next action we want to do is to decrement from. So we add an action which is write global state, and the global state value is going to be decrement from, and the variable we are going to write is deduct. So let's see. Okay, so that's right. So we want to write deduct to decrement from, and then the next line of action we'd want to do is to approve the transaction. Now else, this condition was to check if the user doesn't have the state set. So if the user okay, this is to check if the user has the state set. So if the state is set, is to remove it and then deduct it. Else, if the user hasn't casted a vote, we'll just simply approve the transaction. So simply, this is what we're gonna do. So we have a simple voting program set, and then for this other transaction or this other routine, I think we don't have a need for this other else, so we could just remove it off. And now we have a simple program set. So let's compile to Python to see the results. So yeah, we have our simple program setup. And then we also have our clear program. So now that we have the approval program and the clear program, we can actually deploy our smart contract to the blockchain. So I'll just quickly do a deploy. So we just use testnet. So it's sending the transaction to the blockchain that we could actually view. So we have the application ID. So we'll go to Algo Explorer.io to look at it. Okay, that's mainnet. So we are going to testnet. So we have our application here. So we could actually inspect the global state schema. So we have the start date and the end date here. We have the negative votes and the positive votes. And yeah, that's basically what we want to build. And then I think you could actually keep on with us by subscribing. Invite your friends to know about ASC Builder, because with ASC Builder you could actually build your smart contracts easily with just a drag and drop interface. So what I would just urge you to do is to subscribe, turn on notifications for this video, and like this video. So thanks for watching, and I'll see you next time. Peace.